This is Module 6, Lesson 7. This is Concept Development. So we're looking at the template page that is a part of your packet you have. So what do we have here? We have two charts with X and Y coordinates. We have coordinate pairs. We have a coordinate plane. What should we start off with? That's right. Let's label our X and Y axis. Okay, I'm going to plot a point through, I'm going to plot a point and I want you to think about the point that I'm plotting really quick. Point B. What do you notice? What can you say about this point? They are equidistant from the x-axis and the y-axis for sure. And their X and Y coordinates are the same. So go ahead and I want you to plot the rest of A, C, and D on your coordinate plane. All right, now connect your points. And this is line AD, line segment AD. What pattern do you notice about the X and Y coordinates? What pattern do you notice on the X and Y coordinates? Think about it for a moment. So when X is 0, so is Y. When X is 1, so is Y. All the way up to 3. The X coordinate equals the Y coordinate. So the X coordinate and the Y coordinate are always equal to one another. Well, the point with coordinates 4, will that be on the same line? Will that fall on line AD? Yes, it will. So if we plotted this up to 4, that would still be on the line. What about 5? Yes, that would all stay in the same line. As long as the X and Y coordinates are the same, the point will be on line segment AD. We can say that the relationship between these coordinates are equal, right? So I'm going to write a rule, and that's what we're going to practice. That's going to be our big idea today, is finding a rule that fits for what our coordinate pairs are doing. So let's write a rule. So let's write it over here. Rule. Let's say X. Well, we could just simply say X and Y are equal. We could say X we could say Y is equal to X. We could say Y is equal to X, Y is equal, X and Y are equal. Here, let's continue to connect those. So our rule. Now, will line segment AD contain the point 10, 10, the coordinates 10, 10? So if I put 10, 10, if this extended, would 10, 10 be on line segment AD? Well, you can't see it on this plane because the numbers stop at 5. But, however, if it kept going, we could see it. So yes, as long as X and Y coordinates of the point are equal, the point will be on the line. So, show me a point on AD whose coordinates are mixed numbers. Could we do 1/2 and 1/2? Could we do 1.5 and 1.5? 2.5 and 2.5? 3.5, 3.5? 4.5, 4.5? Yes. So that is also on this on the line AD. So, but my question for you is, can AD contain a point? So can AD contain a point where the x coordinate is a mixed number and the y coordinate is not? So let's say 1.5 and 1. Would that be on line AD? How about 2.5 and 2? Would that be on? No. 3.5 and 3? No, but I have a feeling they would end up being parallel to each other. So think about that for a moment. Actually, put your fingers on the chart. What if you went 1.5 and, half and 1.5? 1.5 and 2.5? 2.5 and 3.5? 3.5, 4.5? 4.5, 5.5. So that line would be parallel to AD on that side. So X and Y need to be equal if they're going to be on line AD. If the X coordinate is a mixed number and the Y coordinate will be the same mixed number. Or it could be expressed in another equivalent form, such as 3/2 and 1.5. So here's a half, 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 1.5, 1.5. So notice when we put those x's, the x and y are equal on that. But if just one of them is, the line would be parallel because it would not sit on that line, right? Okay. So just give me a coordinate pair of a point that would not fall on AD. So what is a coordinate pair that would not fall on line AD? Well, 3 and 2.5 would not fall on that line. All right, so now let's look at this chart here. For points G through J, what pattern do you notice in these coordinate pairs? What pattern do you notice? Okay, it's 0 and 3, 1/2 and 3.5. Okay, 1 and 4, 1.5 and 4.5. So the x and y aren't equal this time. The y coordinate is always more than the x coordinate. The x coordinate is increasing. So the x coordinate is increasing by 1/2, correct? 0, 1/2, 1, 1.5. And then the y coordinate is increasing. It starts at 3, 3.5, 4, 4.5. It also is increasing by 1/2. So the y coordinate is always 3 more than the x coordinate. So let's go ahead and plot the points from this chart B onto our coordinate plane and then connect them in the order that they are plotted. And then I want you to draw a line and connect the points. I want you to stop and Pay attention to what you noticed. Okay, so now that you plotted the points and you connected it, what do you notice? Well, all of these points are in the same line, correct? These points are called collinear. Let's write that word down. Collinear. Collinear. Oh, 2 L's. Collinear. So the relationship between each x and its corresponding y will be the same. Now, if you were to continue, so if this is 0, this is a half, this is 1, this is 1.5, what would the next number be for x? Right, it would be 2 because they're increasing by a half. Now, so automatically, what do you think the next number would be here for the y? Well, it starts at 3, increases to 3.5, goes to 4, goes to 4.5. What would be the next number? 5. Correct? So, what I want you to do by yourself really quick is I want you to write a rule. Use x is, y is, y does this, x does this. I want you to write it somewhere on the side here. Go ahead and go. Okay, so how did you do? So we know when x equals 2, y equals 3. Well, we know that. No, y equals 5. Y is equal to 3 more than x. Y is equal to 3 more than x. That could be your rule. You could also say add 3 to the x coordinate to get y. So whatever this is, add 3 to get the y coordinate. So stop and ponder that. Think about that for just a moment. How did I get that rule? How did I write it down? There are different ways to write it down, but these are probably the 2 easiest ways. All right, now I want you to come up and I want you to write your rule for this chart on this side. All right, so were you able to write something like this? X and y are equal. Y is equal to x. X is equal to y. All right, turn your page and I want you to look at these 4 boxes with these 4 points. And I'm going to ask you to try to identify the coordinate system right here, the lines that those would most likely form. And I want you to identify, tell me which box goes with what. When I'm going to say the rule, you tell me which box it goes on. So, which chart shows coordinate pairs for the rule y is always 3? Y is always 3. The y coordinate is always 3. So, let's write that down. It's A, of course. Y is always, let's say, equal to 3. So y is always 3 beneath, we'll just write it right here. Okay. So which chart shows every y coordinate is less than every x coordinate? Okay, I'll say it again. Point, which chart shows every y coordinate is less than every x coordinate? Every y coordinate is less than the x. Which chart shows every y coordinate is less than every x coordinate? Can you figure it out? Yes, it is C. So x is each y coordinate minus a half. So we could write this as y coordinate, we'll just abbreviate, is less than the x coordinate. What is another way we could write that? Well, we could be more specific. We could say y is 1/2 less than x. Or we could say y is 1/2, let's say 1/2 less than x. Okay, that's our first one here. You could say subtract half. Subtract half from x to get y. So y is 1/2 less than x. So, okay. Which chart shows coordinate pairs on a line that follows the y is x times 2? Y is x times 2. Y is x times 2. Y is equal to x times 2. That's right, it's B. So, y is equal to x times 2. Because 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. So y is equal to x times 2. Let's see if you can come up with any others on your own to describe that. How about y is double x? Y is twice as much as x? Y is twice as much as x. X is half of y. Another one you could put. X is half of y. All right. Now, our final one. What do you think the rule could be for this one? All right. Were you able to think through and decide what this kind of rule? What could you write for that? How about y is x times 3? Y is 3 times more than x. And then how about triple? You could triple x to get y. So this right here is the big idea for today. Can you name a rule to go with how the coordinate pairs, how the relationship between the coordinate pairs, the relationship between the x and the y? All right. So go back. I want you to read each one of these really quick and make sure you understand the big idea, the rule that goes with the coordinate pair. All right. The last thing you're going to do here, you are going to point you are going to plot the points for this group of coordinate pairs, 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 and this group of coordinate pairs. And then draw a line to connect the 3 points. Go ahead and go. Okay, so does your coordinate plane look like this? Were you able to label your points and connect them? Now, I'm going to show you some coordinate pairs. I'd like you to tell me which line the point would fall on. Okay, and be prepared to I know, so 5, 10. Where would 5, 10 fall on this line? Which line? This line up here, 5, 10. Now, why do you think 5, 10 would be on that line right there? Well, x times 2, right? That would go with the x times 2. Because 5 times 2 is 10, and this follows the pattern in chart B. If it's the same as the chart in chart B, if you double x, which is 5, you get 10, which is y. The y coordinate is twice as much as the x coordinate in this pair. That's the same relationship as the other points on the line shown for chart B. Now, what about 5 and 4.5? Where would 5 and 4.5 fall? It would fall on point C, if you will, because it would be 1 and 1.5. 1 and 1.5. Wait, 1. Oh, and a half. And then 2 and 1.5. 3 and 2.5. So if I went to 5, would it end up on 4.5? Oh, yes, it would. This would be on here. This would be on here. Now, so 5, how do you know? Well, 5 minus a half is 4.5. The y coordinate is half less than the x coordinate. Now, finally, what about the point half and 1.5? Where would half and 1.5 fall? A half. Does anything go up by a half and then increase by 1.5? Half. What have you decided on? That would fall in the x times 3. So 3 times a half is 3 halves, which is 1.5. The y coordinate is 3 times as much as the x coordinate. Now let's try 1.5 and 3. So where would this guy fall? What chart would he fall into? He would actually fall into the x times 2. Y is always 3. Oh, y is always 3. Both rules are correct because this point is on both lines. This point is on both lines. Check that out. Because this point falls, it shares two lines. It's a point on both lines. That means it can actually share two rules. So both rules are correct because this point is on both lines. The same point can be part of more than just one line at a time. Now, how do you know if this coordinate pair would appear in both charts? Well, the two lines cross each other at the point the lines intersect. They intersect at 1.5 and 3. So, what happens with the coordinate pair 0, 0? Well, 0, 0 is x times 2 and x times 3. So again, the point 0, 0 lies on both lines. Does that seem consistent with what we've seen when we looked at lines themselves? Well, yes, you can see both lines going through the same point. If a line intersects at the same point, that point can share two rules. So keep that in mind. This is the end of the concept development. Moving on to the problem set. The problem set, you're going to plot points. You're going to find the rules. You're going to use the coordinate plane below to answer the following questions. What do you notice? Trying to find the rule, trying to identify what you can say is similar or different. You're going to complete the chart for your exit ticket, and then you have your homework.